US, Europe, and now Asia. We just finished Oracle Code Japan, which was an awesome event. We're on a motorcycle tour following that event, traveling across Japan, visiting different user groups. The reason why Oracle's reaching out to developers is the way people buy software, services, and products has really changed. Now, developers have a lot more control over the technologies they use, so we want to directly engage with developers, teach them about some new open source technologies, and then show them that those technologies which we're using run very well on the Oracle Cloud. One of the big advantages Oracle has is having a very large community. So by building on top of our stack, you're not only getting the Oracle products and services which run on our cloud technology, but you're also getting a lot of community support from folks in those open source technology communities. So there's over 300 Java user groups globally, Java user groups and the Oracle user groups. They run their own events, they talk about technologies, they help folks get up to speed on how they can use our cloud technologies and platforms, and you can be part of the community. Basically, we're traveling across Japan and stopping at a dozen user groups in between via motorcycle, so it's a very efficient way to hit up a bunch of different communities throughout Japan. In the big cities, you get large numbers of developers because there's large consulting companies, a lot of software development happening there. But in the smaller areas of Japan, you get a very local flavor to the communities and the user groups, and there's large user group communities. But they don't always get the attention and the visibility which they would get normally if they were in a large hub like Tokyo. On this tour, we have Sebastian Daschner, who is a Java champion from Germany. He's presenting about cloud-native Java development. We have Kirk Pepperdine, who is a internationally known performance tuning guru. And lastly, we have David Delabase, who is a Java EE and WebLogic evangelist for Oracle. It's great that we share a common interest in motorcycling, and we're able to use that to spread a little bit of our passion about Java to the global user group. I've been traveling around to a bunch of the Oracle Code events worldwide. We've done these across the US, Europe, and now Asia. We just finished Oracle Code Japan, which was an awesome event. We're on a motorcycle tour following that event, traveling across Japan, visiting different user groups. The reason why Oracle's reaching out to developers is the way people buy software, services, and products has really changed. Now, developers have a lot more control over the technologies they use, so we want to directly engage with developers, teach them about some new open source technologies, and then show them that those technologies which we're using run very well on the Oracle Cloud. One of the big advantages Oracle has is having a very large community. So by building on top of our stack, you're not only getting the Oracle products and services which run on our cloud technology, but you're also getting a lot of community support from folks in those open source technology communities. So there's over 300 Java user groups globally, Java user groups and the Oracle user groups. They run their own events, they talk about technologies, they help folks get up to speed on how they can use our cloud technologies and platforms, and you can be part of the community. Basically, we're traveling across Japan and stopping at a dozen user groups in between via motorcycle, so it's a very efficient way to hit up a bunch of different communities throughout Japan. In the big cities, you get large numbers of developers because there's large consulting companies, a lot of software development happening there. But in the smaller areas of Japan, you get a very local flavor to the communities and the user groups, and there's large user group communities. But they don't always get the attention and the visibility which they would get normally if they were in a large hub like Tokyo. On this tour, we have Sebastian Daschner, who is a Java champion from Germany. He's presenting about cloud-native Java development. We have Kirk Pepperdine, who is a internationally known performance tuning guru. And lastly, we have David Delabase, who is a Java EE and WebLogic evangelist for Oracle. It's great that we share a common interest in motorcycling, and we're able to use that to spread a little bit of our passion about Java to the global user group. I've been traveling around to a bunch of the Oracle Code events worldwide. We've done these across the US, Europe, and now Asia. We just finished Oracle Code Japan, which was an awesome event. We're on a motorcycle tour following that event, traveling across Japan, visiting different user groups. The reason why Oracle's reaching out to developers is the way people buy software, services, and products has really changed. Now, developers have a lot more control over the technologies they use, so we want to directly engage with developers, teach them about some new open source technologies, and then show them that those technologies which we're using run very well on the Oracle Cloud. One of the big advantages Oracle has is having a very large community. So by building on top of our stack, you're not only getting the Oracle products and services which run on our cloud technology, but you're also getting a lot of community support from folks in those open source technology communities. So there's over 300 Java user groups globally, Java user groups and the Oracle user groups. They run their own events, they talk about technologies, they help folks get up to speed on how they can use our cloud technologies and platforms, and you can be part of the community. Basically, we're traveling across Japan and stopping at a dozen user groups in between via motorcycle, so it's a very efficient way to hit up a bunch of different communities throughout Japan. In the big cities, you get large numbers of developers because there's large consulting companies, a lot of software development happening there. But in the smaller areas of Japan, you get a very local flavor to the communities and the user groups, and there's large user group communities. But they don't always get the attention and the visibility which they would get normally if they were in a large hub like Tokyo. On this tour, we have Sebastian Daschner, who is a Java champion from Germany. He's presenting about cloud-native Java development. We have Kirk Pepperdine, who is a internationally known performance tuning guru. And lastly, we have David Delabase, who is a Java EE and WebLogic evangelist for Oracle. It's great that we share a common interest in motorcycling, and we're able to use that to spread a little bit of our passion about Java to the global user group. I've been traveling around to a bunch of the Oracle Code events worldwide. We've done these across the US, Europe, and now Asia. We just finished Oracle Code Japan, which was an awesome event. We're on a motorcycle tour following that event, traveling across Japan, visiting different user groups. The reason why Oracle's reaching out to developers is the way people buy software, services, and products has really changed. Now, developers have a lot more control over the technologies they use, so we want to directly engage with developers, teach them about some new open source technologies, and then show them that those technologies which we're using run very well on the Oracle Cloud. One of the big advantages Oracle has is having a very large community. So by building on top of our stack, you're not only getting the Oracle products and services which run on our cloud technology, but you're also getting a lot of community support from folks in those open source technology communities. So there's over 300 Java user groups globally, Java user groups and the Oracle user groups. They run their own events, they talk about technologies, they help folks get up to speed on how they can use our cloud technologies and platforms, and you can be part of the community. Basically, we're traveling across Japan and stopping at a dozen user groups in between via motorcycle, so it's a very efficient way to hit up a bunch of different communities throughout Japan. In the big cities, you get large numbers of developers because there's large consulting companies, a lot of software development happening there. But in the smaller areas of Japan, you get a very local flavor to the communities and the user groups, and there's large user group communities. But they don't always get the attention and the visibility which they would get normally if they were in a large hub like Tokyo. On this tour, we have Sebastian Daschner, who is a Java champion from Germany. He's presenting about cloud-native Java development. We have Kirk Pepperdine, who is a internationally known performance tuning guru. And lastly, we have David Delabase, who is a Java EE and WebLogic evangelist for Oracle. It's great that we share a common interest in motorcycling, and we're able to use that to spread a little bit of our passion about Java to the global user group.
Developers build the future. We take ideas and make them real. My job is to think, create, and solve for a living.
Each step we take is possible because someone asked the questions. Why do we have to do it this way? What if we did it that way?
Each step I take enables people to go further. Be creative. Change something. I'm working on blockchain that will change asset identity.
Artificial intelligence to automate homes.
Autonomous robots to improve efficiency.
My app is advancing human rights.
I build things to help connect people. Not everyone gets to build their passion. We share what we know. We share what we do.
We try, learn, try again.
Make, break, build.
All right, good morning, everyone. So my name's Stephen Chin. I'm the content chair for Oracle Code, and I also run the Groundbreakers team. And I'd like to invite Gitu Bhatnagar, who is the Chief Marketing Officer of India, to help open our event. So, Gitu.
Thank you, Stephen. A very good morning, girls and boys, and dear friends. Welcome to this 2019 edition of Oracle Code. So most of you would be aware of Oracle Code as a series. Today, the buzz is going to be on the latest and the greatest technologies from Oracle. Last year, when we were here in this city as well, we also ran a very special series called Women in IT. Today as well, since last week was the International Women's Day, the theme was Balance for Better. We really encourage and engage women leaders and women coders to join the session today, 4:30, Women in IT over IT. What I also want to highlight today, we have the social wall going, we have a lot of social momentum being built, so I encourage all of you to use the hashtag Oracle Code and share your insights and perspectives through the day. Let's build the buzz in the city together. So in Greek mythology, a torch is actually symbolic of change and human involvement and human achievement. So with that background, I would actually want to light the torch today to ensure the commitment of Oracle for all the developers in this room and actually to engage and build this momentum further. Thank you. Let's hear a buzz. Thank you, Stephen. With this, I hand over the baton to you to open the forum for the day.
All right,
Thank
you,
you.
Gitu. This is very inspirational. So without further ado, I'd like to introduce our first keynote presenter. So I'm sure you all know Scott Davis. He's going to come up and he's going to talk to us a little bit about development technologies. Scott, please come up on stage and give him a big round of applause.
Oh, it's so nice to have you here. I've been coming to Bangalore now for, twice a year for the past decade. I absolutely love your fair city. Go to Lalbagh whenever I get a chance. Go to Cubbon Park whenever I get a chance. And eat lots of Mysore masala dosa while I'm here. So I hope that this presentation this morning will be inspirational. It might be depressing as well. You get to decide which it is. Maybe it'll be both depressing and inspirational. But we're here to talk about the wrong kind of fast. And more importantly, how to fix it through what I call evidence-based architecture. So, as Stephen mentioned, my name is Scott Davis. I'm a principal engineer and web architect with ThoughtWorks. I'm so happy to hear talk about women in technology. ThoughtWorks has won the Grace Hopper Award for Women in Technology 3 years running. Our CTO, Rebecca Parsons, was just recently given an award by the Grace Hopper Institute as well. So women in technology is something that's very important to us at ThoughtWorks as well. You know, Stephen is part of the user group community, helped promoting user groups within Oracle. And it made me realize that I was the president of the Denver Java user group, Denver, Colorado, that's where I'm from, over 20 years ago. I ran the Boulder Java user group for a number of years as well. So if you're not a member of the user group community, if you aren't regularly attending a meetup in your local area, seek them out and find them. They're such a wonderful way to level up your skills in this industry and really commit to what we do for a living here. But as I'm looking back, I'm an author. I've written for IBM, I've written for O'Reilly, I've written for the Pragmatic Bookshelf. My very first book was J-Boss at Work over 20 years ago. So that gives you an idea of longevity of this language in our community. So you might be wondering why I'm here talking to you today about frozen waffles. How many of you have had a frozen waffle before? Oh, not many, all right. Do they sell frozen dosa in the store? No? Then you'll get an idea of how delicious frozen waffles are as a breakfast item. These are things that you serve to toddlers who can't talk yet, who can't say, "Mommy, this tastes terrible, stop feeding these to me." Yes? These are also the staple of starving university students who say, "Mommy, send money, I'm tired of eating frozen waffles as I'm pursuing my degree." But see, frozen waffles, when my wife and I talked to each other, we said, why do we buy these things? We realize it's due to the advertising, right? In the advertising, they say it's fast, it's low cost, it's convenient. They never mention that it tastes good. But you're busy. You're too busy. And so we're here to help. Oh, you're here to help, are you? Yes. Yes, we don't need that kind of help, but thank you. And so after a couple of years, my wife and I realized that, oh, you know what? We do have time. We do have time to make waffles for scratch for our children in the morning. And so we moved on to a box mix, Bisquick. Quick is in the name, right? So it must be fast. And if you look at these ingredients, it's not hard to put these together. In 5 minutes, we mix up a batch. Another 5 minutes, we've cooked them up for our children. And these were better. They took a little bit more time, but they were a little bit better to eat as well. But there was a problem with our Bisquick waffles as well. First of all, look how many it serves. I'm from a family of 4, and it served 12. So that meant everyone ate one waffle, and Dad ate the rest, right? That's no good. That's no good. But here's the other problem with making boxed waffles. We came to realize that our waffles tasted just like our pancakes. And our pancakes tasted like our biscuits, and our biscuits tasted like our muffins. You get the idea, right? This was a jack-of-all-trades, master-of-none solution to making breakfasts in the morning. So what we finally came across, waffles of insane greatness. This is a real recipe. I encourage you to look for it on the internet. Waffles of insane greatness. Oh, they're so good. They are so good. As a matter of fact, here's the recipe for you right here. And if you look at that recipe, you might say, oh, wait, there's so much more going on. And in practice, we found that we were spending the same 5 minutes making waffles of insane greatness as we were making cheap boxed waffles. But if you look at the ingredients, we added cornstarch so it made them light and fluffy and crispy. We added buttermilk to add richness. We added vanilla to really bring out the taste. Have you ever invited friends over to serve them frozen waffles? Probably not. You eat that in shame, all right? In the cover of darkness. We've invited friends over to eat waffles of insane greatness, though. They are that good. So, what I'd like to introduce you to this morning is the waffle quality curve. Stick with me. There's a reason for all of this, I promise. Yes? We realize that frozen waffles are the fastest, but also the lowest quality. And as we add prep time to this solution, we find that box mix, adding a little bit of extra time, adds a little bit more quality. But making waffles from scratch, a purpose-built solution, adds not much more time to the preparation, but dramatically improves the quality of the outcome. Yes? So you're asking yourself, what does this have to do with web development? Well, nothing at all. I missed breakfast this morning. I was very hungry. I just thought I would discuss breakfast with you this morning. No. What does this have to do with web development? Well, the waffle quality curve, in fact, is closely related to the web quality curve. Now, I don't want anyone to get upset by the real names here. I'm not here to pick on WordPress. I'm certainly not here to pick on React, but these give you an idea of where they fit on the spectrum. We have pre-built solutions like WordPress, like Docker, many of the things that you just download and use instantly. We have things that require a little bit more time, like React, like Angular, like Vue, like these frameworks. And many web developers feel that that is the pinnacle of web development right there. And in fact, I'm here to suggest that if you invest the same amount of time, but in purpose-built technology, browser-native technology like HTML5 and CSS and JavaScript, you'll be spending the same amount of time, but dramatically improving the results. Yeah? So, if we go out to Angular's website and read the fine print, they say, oh, look, you can develop across all platforms. One framework will solve your mobile problems and your laptop and your desktop problems. They said, oh, you can achieve the maximum speed possible on the web platform. Yeah? That sounds an awful lot like Bisquick, doesn't it? Yes. And we start looking at something. And this is something we all know, that when you try to make one thing do more than one thing, it does nothing but add complexity. And it also lowers the quality across everything you're trying to accomplish. React. How many of you use React in production right now? A few hands go up, very good. Are any of you using React Native in production? A couple hands go up. Okay, React server-side rendering. Oh, one hand goes up. You're a brave fellow. Thank you for raising your hand. React is an incredibly powerful, popular framework. And its key selling point is it's a virtual DOM. It abstracts you away from the DOM. So they say, look, a React app can be a native app. It can be server-side rendered as well. But as we saw here, so many of my clients use React, but don't use React Native, don't use server-side rendering. And at that point, they're paying all of the costs of this complicated framework and realizing very, very few of the benefits. So, when people say, React is faster than the DOM, Dan Abramoff, who is the founder of Redux, who is the lead contributor to React, he says, no, React is not faster than the DOM. We don't claim that. React can't be faster than the same DOM manipulations written by hand because by definition, React has to do more work. This is a very sensible response. I've never met Dan in person, but this is a reasonable response. I like that. He goes on to say that we think, in fact, that React helps us create maintainable applications, and it is fast enough. Fast enough. Now, what's interesting about that is now we're into something that is measurable. We can actually measure what fast enough means. And this is a good thing. This is a good thing. So the first thing I want to talk to you this morning about is measuring performance. We will also talk about measuring DevOps, and we will talk about writing fitness functions. So here we are in Act 1, measuring performance. And I love the internet. I love it when someone goes out and does my job for me so I don't have to do the hard work, right? Someone has gone out and actually written an article about the performance cost of server-side rendering React. And what I like about this article is the fact that he starts by saying, I like React as a templating engine. This is not a hit job. This isn't someone taking cheap shots. This is someone who likes React. I like the concept of guarantees of structure and validity. However, I do recognize that there's overhead in what React brings. And this is where we get to measure the cost of React. The author said, hey, I went out and I created a simple Node app that was nothing more than a simple HTML page with 100 table rows of employee data. This is not a complicated app. But with 100 rows of employee data on there, he turned around and used pure JavaScript templating, ES6, ECMAScript 6 templating, pure JavaScript templating to see how long that would take. He selected Nunjux and Pug. Pug used to be a very popular framework called Jade, if you're familiar with Jade. Very fast, very popular. So he used a couple of industry-leading frameworks to kind of measure things up. Of course, he included React, but my favorite part is he said, for measure, I threw in a simple Node server that dumped the content as static HTML. As all good scientists know, if we're going to use evidence, what we need is a control to measure all of our changes against. So this is actually a very good experiment and something that we could all write in our organizations, and I hope we do write things like this. So, what are the results? I know the numbers are very small. It's not important. Do you see this tiny green bar, the lowest bar on the graph? That's React. Now, to the author's credit, he says, now that was actually React in dev mode, in developer mode. So when he turned React into production mode, that is now this purple bar, the second shortest bar on the list. Yes? This graph is measuring throughput for one concurrent user, 5 concurrent users, 50, 100, and 250. So at 250 concurrent users, server-side rendered React served up 1,600 responses per second. And while that's respectable and very well might be fast enough, what we begin seeing is the dark blue bar is pure JavaScript, twice as fast. When we look at this light blue bar, that is static HTML, 3 times as fast, right? We can measure what fast enough is. And again, my goal here is not to knock React, no more than the original author is. We're talking objective numbers here. It very well could be that 1,600 requests per second is fast enough. Then you've made the right decision. But if you're measuring performance, it's important that we have real numbers to look at. Now, this is throughput. If you look at the opposite end of this, how much is the response time for an individual request? That long green bar, tall is bad in this case, is React. The next tallest bar, 149, 150 milliseconds, is React. Pure JavaScript is half that, 70 milliseconds per response. And HTML is 5 times as fast. So we can measure performance. We can measure how fast things are. And this is good, and this is healthy. This is what I mean by evidence-based architecture. It's easy for us to say, oh, we want our app to be performant. But that's not specific and measurable. We want our app to be fast. Well, of course we do. But how fast? So in order to do something like this, we need to set up a budget. Not a financial budget, but in fact, a performance budget. And if you're going to set up a performance budget, it must be 2 things. It must be measurable, and it must have targets. We can't say we want our website to be responsive. We want to be very specific. We can't say we want our website to be fast. We want it to be specific. So when I walk into any client without looking at their app or anything, I say, here are 2 things we should start at. We should have a page weight that's under a megabyte, and we should have time to interactive at under 3 seconds. Those are specific and measurable. Why do I pick those numbers? Well, because 1 megabyte takes about 5 seconds to download on a 3G network. 1 megabyte takes 5 seconds to download. And fun fact, over 75% of the world is on a 3G or slower network. So these are good numbers to track. As a matter of fact, this is the text I got when I landed in Mumbai a couple days ago. Congratulations, here is your free 2G data plan. Oh, thank you so much, T-Mobile. I won't know what to do with all of the bytes that you offer up, all 7 of them. So this idea of measuring performance, this idea of measuring page weights and measuring time to interactive, in some ways is in fact measuring JavaScript. Because we saw that HTML and CSS is so fast, it's declarative, it's implemented in C and C++, you won't get any faster than plain HTML and CSS. That is always going to be your baseline. And I'm a programmer myself. I'm not here telling us never to write any JavaScript again. As a matter of fact, Alex Russell with Google said it best. He said, JavaScript is like carbon dioxide. We need some in the environment, yes, or we all die. If we have too much in the environment, we all die as well. So it's a matter of finding how much JavaScript is appropriate. What is fast enough? So these are median numbers. And just to remind you of your basic elementary school math, right? We know of averages, which is adding up all the numbers and dividing it by half. The median is actually the point where half of the people are faster than you and half of the people are slower than you. So it's similar to average, but not identical. The median is where you're standing right at the top of the hill and you're looking down one side of the hill and looking down the other side of the hill. So half of the internet downloads less than 350 kilobytes of JavaScript. That's compressed. Uncompressed, that's a megabyte. So right there, you've hit your performance budget. Half of the internet is faster than 15 seconds to time to interactive. Now you know that if your website takes longer than 3 seconds to become active, you lose over half of your users. Over 50% of your users will leave if it takes longer than 3 seconds. eBay has measured that they, not eBay, I'm going to lie to you right now. Walmart, I'm not lying to you. Walmart has figured out that for every 100 milliseconds they reduced, their revenue went up 1%. These are very, very real numbers. And if our target is 3 seconds and our median is 15 seconds, you can see that we're off, aren't we? We have work to do here. Page weight is very closely relative to our performance as well. So these numbers are from the HTTP archive as well. The HTTP archive, by the way, is a free website. You can go to HTTP archive yourself, and you can run these reports. This is over 8 million websites that get scanned several times a month. Public websites. So this is a very large data set, a very trustworthy data set. And say at the 50th percentile, at the median, half of the web pages have more than 1.5 meg page weight, and half of the websites have less. So when I come in and I'm asking you to have less than 1 megabyte of page weight, I'm not asking unreasonable things. I'm only asking you to be better than half of the websites out there. That seems reasonable to me. That's not unreasonable at all. And if you look at the 90th percentile, page weight of close to 6 megabytes, when 1 megabyte is our goal, you say, oh, how can that be? That can't possibly anyone I know, can it? Oh, in fact, it is people we know. Google Sheets on desktop is close to 6 megabytes right there. Facebook is 7 megabytes. LinkedIn is over megabytes. We begin seeing there's a huge gap in between what our mainstream websites are doing and what we know about user behavior. What we know about what is good on mobile versus what we're already doing on mobile. Now, there's one lie in this slide. I'll see if you can find it. This is, in fact, Margaret Hamilton. She is the woman who wrote the code that put American astronauts on the moon, the Apollo 11 project. So this is Margaret Hamilton standing next to the code that she wrote that put men on the moon. She is also the woman who coined the phrase software engineer. If you call yourself a software engineer, you have Margaret Hamilton to thank for that. Now, the lie in this slide is that this isn't the contents of her node modules directory for a Hello World React app, okay? That's the lie. But what I love about the internet is someone said, you know, what if we did calculate what the node modules directory of a Hello World app for React would actually take? And so he goes through and does some back of the envelope calculations. He says, I figure we can get about 49 line code per page. And I figure that there are about 2.6 million lines of code in the dependencies for a Hello World React app. 2.6 million lines of code for a Hello World app. Is that state of the art? He goes on to calculate that a sheet of a paper is about 0.1 millimeters thick, and so by the powers invested in him, the mathematical powers, he calculates that Margaret is in fact 18 feet tall if she is standing next to the code in her React Hello World app. 18 feet tall. In reality, she's 5 feet tall. Now, someone helpfully pointed out on the internet that, hey, if you printed it out double spaced, Margaret would only be 9 feet tall. Does that make you feel better? Yeah? Yeah. So we see that these are real numbers. These are discoverable numbers. These are knowable numbers. Netflix, when they removed React from their homepage, increased their time to interactive by 50%. When they removed React from their homepage, the splash page that says, welcome, would you like to log in or create a new account? They discovered they didn't need the overhead of a framework to handle 2 buttons on a login form. They wrote this in vanilla HTML and CSS and JavaScript and improved their time to interactive by 50%. Look for this on the net. This is a great keynote. It's only about 15, 17 minutes long, shorter than mine. And they go into details of how they calculated their time to interactive, how they calculated these things. It's a very interesting keynote. Because we see this idea of time to interactive maybe isn't something we're familiar with. We know that in the life cycle of these browsers, navigation begins on a blank, empty page, nothing but opportunity, right? And then we see the first contentful paint. That is one metric that some people track, FCP, first contentful paint. That's the first thing you see a pixel show up on your screen. I think that's less interesting than as we move along that path to time to interactive. Because one very real user concern is they pull up a mobile app on their phone and they start tapping on it and nothing happens. That's why TTI, time to interactive, is such a crucial metric because it is a user-focused metric, not a developer-focused metric. How many presentations have you been to where the developer stands up on stage and says, hey, I'm going to build a Twitter app for you in 20 minutes using this hot new framework? That's talking about DX, right? The developer experience. And we're all developers, and so that appeals to us, that resonates to us. But in fact, we should be focusing less on DX and more on UX, the user experience. And time to interactive is how we measure that. I don't know if you've heard of Google AMP before, Accelerated Mobile Pages. The punchline is in the title, Accelerated Mobile Pages. Over 1.5 billion AMP pages have been published across a number of different publishers. And what they find, the way they get this accelerated in Accelerated Mobile Pages, is AMP pages can't include any author-written JavaScript. It can't include JavaScript. It can include HTML. It includes CSS. It can include web components, which has JavaScript inside of it, but no free-range JavaScript on this page. Of course, there are other things that they do as well, but what does this one important change do? It means that the Times of India sees a 3.5 time page load increase. Jagran, India Today. These are all real, measurable numbers. And if we look at this 3.5 times faster, that is the same order of magnitude we saw in our own experiment in React versus static HTML, isn't it? We saw a 5x improvement between React and static HTML. They say a 3x improvement. So that is definitely in line with what we've experienced ourselves personally. Wired uses AMP. Gizmodo uses AMP. The Washington Post. And all of these are case studies you can drill into and read more about. The Washington Post one I find especially interesting. They say if our site takes a long time to load, it doesn't matter how great our journalism is. Some people will simply leave the page before they see what's there. This is what we're talking about, isn't it? The wrong kind of fast. And they go on to say that we publish over 1,000 AMP articles a day, and our average performance time is 400 milliseconds. Less than half a second. These are real numbers. These are achievable numbers. And this is why we should be setting up performance budgets of our own. So we do need a performance budget. The numbers are up to you to decide, but you should be tracking page weight. You'll most likely be tracking the size of JavaScript and the size of images. You should be tracking TTI, maybe First Contentful Paint, but these are the kinds of things that we can be tracking. Does that make sense? Ah, very good. Well, now that we've talked about our application itself, developers, let's talk about DevOps. All the things that go around the development process, right? Some people argue this is where the interesting bits happen. Yeah? Do you remember our frozen waffles? Do you remember our recipe for waffles that included things like flour and milk and eggs? Did our waffles of insane greatness include monocalcium phosphate and soy lecithin and yellow dye number 5? I don't remember adding yellow dye number 5 to my waffles. Maybe I did and I just didn't remember it. Yes? When we have these free things, we find that they come at a cost. And, oh yeah, the top 10 Docker images have at least 30 security vulnerabilities baked into them. That's the wrong kind of fast, isn't it? And that's not average across all of them. That's Ubuntu over here on the right. Number 10 has only 30 security vulnerabilities. If we look at Redis and Memcache and Couchbase, they all have 50 security flaws baked in. If we look at MySQL and Mongo and HTTP, they have between 60 and 70 errors baked in. Nginx and Postgres have close to 90, and oh, Node.js, congratulations, you win! 580 security flaws baked into the Docker image. This is the wrong kind of fast. This is the wrong kind of fast. Oh, and I wish I could say that by using a JavaScript framework, you wouldn't have that problem. No, it's additive. It compounds to that. They did the same study over 133,000 websites. And what did they discover? 37% of all jQuery includes have a known security flaw. 40% of all Angular includes have a security flaw. 87% of all handlebars libraries have a known security flaw. This is a sobering finding, isn't it? It's so easy to npm install these things. We think we're getting away with something for nothing, don't we? We think that npm install is wonderful, and it is wonderful, but there is something we need to take responsibility for as well, and that's security. In this study, they discovered that the median website had at least one library that was over 3 years old. The median website. That means half of the websites had newer libraries, and half of the websites had older libraries, right? Do you remember reading about the Equifax scandal? That was because they were using Struts 2. There was a known security patch. The Struts 2 team patched it within a day of finding it. The patch had been released for over 2 months. Equifax didn't upgrade their framework. Equifax didn't upgrade their framework, and they compromised 143 million consumers' private information. And if you talk to the CTO later in this article, he said, it wasn't a simple patch upgrade away. We could have done an NPM upgrade, right? We could have done that. We said we were so far behind that a simple patch would not have solved this problem. And that is true across all 133,000 websites that the survey looked like. When they looked at it, they said less than 3% of all websites could become free of vulnerabilities by applying patch level upgrades. When you are 3 years behind, you are a long way away from a simple NPM update to solve the problem. Sobering, isn't it? Sobering. But wait, there's more. I told you, are you feeling inspired or depressed at this point? Don't worry, we'll turn the corner. We'll get inspirational at the end, okay? There's a little bit more depression, so settle in, okay? Yes. WebAIM, talking about accessibility. What did they do? They surveyed the top 1 million websites for accessibility, for people with low vision and low hearing, and all the manner of accessibility issues. What was the number they discovered? 98% of all home pages had at least one accessibility issue. We win! You never get close to 100% consensus across the internet, didn't we? And we've got 100% consensus that we are going to have accessibility flaws in our homepage. There was one flaw for every 13 elements in a page. So not just one flaw. We found that 85% of all home pages had low contrast text, so people with low vision could not read the text. We found that 68% had missing alt tags for their images. We found that close to 60% had empty links. These are easy problems to solve. So why weren't they solved? Because when they correlated accessibility errors with frameworks, the numbers got even more depressing. Now they say that the adoption of any of these frameworks is aligned with additional accessibility errors. It doesn't mean that the framework caused these errors, but we do have a correlation between using these frameworks and an increased number of accessibility errors. If you use React, there were 10% more errors on pages of website that used React. If you used Angular, there was 20% more errors. If you used Vue, there was close to 25% more errors. Sobering, isn't it? We think that frameworks are solving these problems for us. We think that by using frameworks, we're outsourcing our need to solve security problems, outsourcing our need to solve accessibility problems. It's still our responsibility. It's still our responsibility. There are lawsuits in North America right now. Winn-Dixie is a grocery store. It was the first grocery store that was successfully sued under the American for Disabilities Act, not for their brick and mortar locations, but for their websites. And in last year alone, there are over 10,000 lawsuits against major websites under the Americans with Disabilities Act. We're getting ready to turn the corner. Have I sufficiently depressed you? That's what a keynote is supposed to do, right? Suck all the energy out of the room. There is a happy ending to this story. DevOps. This is a wonderful book, Accelerate. If you've not read it, I encourage you to check it out. Written by Nicole Ferguson, a PhD, but also Jez Humble, a former thought worker who worked on cruise control, who worked on GoCD. ThoughtWorks has been doing continuous integration and continuous delivery for over 15 years. Many of you might be familiar with Jenkins and Hudson. Our application, our free and open source application, Cruise Control, predates Jenkins by about half a dozen years. So we've been doing this for a long time. This book is a scientific study by an academic submitted in peer-reviewed journals. They collected data for over 23,000 survey entries, 2,000 organizations. And what did they find? They found that compared to low performers, high performers have 46 times more frequent code deployments, 440 faster lead time from commit to deploy, 170 times faster mean time to recover, and they had 5 times lower errors. This is the difference between high-performing organizations and low-performing organizations. If you don't have a continuous delivery pipeline in place that allows you to do 40 to 50 commits to your website a day, because that's what the major websites are doing. The Googles and the Twitters and the Facebooks commit to their website 40 to 50 times a day. And not only are they able to commit, they're able to roll back in the face of errors as well. I come into organizations that are 90 days behind on their monthly deployment. I said, you keep saying that word monthly deployment. I don't think it means what you think it means, right? If you are 90 days behind, you should be deploying 90 times a day, not once every 90 days. So the takeaway from all this is that increase in responsiveness doesn't come at a cost from stability. You remember Facebook's old saying, move fast and break things? What Accelerate has discovered is the opposite is true. High-performing companies move fast and don't break things. Break things 5 times less than less mature organizations. So there is a solution in place. If we turn around and have a good continuous delivery pipeline in place, we can start solving these problems. And how are we going to solve these problems? We're going to solve them with fitness functions. Now, I don't even need to ask how many of you are writing unit tests, right? All of you are writing unit tests, right? Nod your head, yes. Yes, Scott, of course. That's exactly what we do. Yes. So you already have 100% code coverage, so I don't need to talk about that. Fitness functions are how you test the health, not of the bricks, but of the building itself. How do you test the health of your website? You knew I'd come back to breakfast, didn't you? This is the toaster I used to have in my kitchen. It's a lovely toaster. It did exactly what I wanted. It burned my Pop-Tarts, it burned my bagels, it burned my toast. 100% of the time, it burned everything I put into it, right? Because what happened? I put a perfectly good slice of bread in, I hit a button, and it disappears. I have no visual indication of what that bread is doing. And the toaster says, pick a number between 1 and 5. And whatever number I picked was wrong. When I changed from a toaster to a toaster oven, this is a real story. We just recently bought a toaster oven. It's brilliant because you can now see what's going on. We haven't burnt a single piece of toast since we added visibility to the process. How many of your deployment processes are this? You hit the deploy button, close your eyes, and hope for the best. How many of your deployment options are like this, where you can see every step of the way? This is what fitness functions are. Fitness functions are discussed in another great book, Building Evolutionary Architectures. This is by Rebecca Parsons, our CTO. This is by Neil Ford, a colleague of mine, a director at ThoughtWorks, and Patrick Kwan. All three of them talked about fitness functions. And really, we're talking about guided change here. This isn't a big bang change. We're going to make one change and track its success. And if it's successful, we'll make another change and track its success, and another, and another. This is a gradual process, but it is achievable. A fitness function is an objective function used to summarize how close a prospective design solution is to achieving our set aims. That's all a fitness function is. You say, this is what I want to accomplish. How close are we to actually accomplishing it? So when we talked about a performance budget earlier, I didn't call it a fitness function then, but that's exactly what it is. If it's measurable and it has targets, it in fact is a fitness function. This is a very real performance budget for The Guardian. They said our product page must ship with less than 170 kilobytes of JavaScript. We must include less than 2 megabytes of images. We have to get closer to time to interactive in under 5 seconds. These are specific. These are measurable. This is a performance budget, and this is a fitness function. And there are lots of fitness functions we can use. Are you familiar with Lighthouse? Show of hands, Lighthouse. Oh, it is baked into Chrome. Every one of you have Lighthouse available to you right now. It's incredibly easy to use. You visit any web page on the internet, any web page at all, whether you own it or not. You go into development tools and click on audits. And in no more than a minute or two later, you have a report that tells you how well you are in terms of progressive web apps, how well you're doing in terms of performance, how well you're doing in terms of accessibility. I can't stress this enough. This is available to every single one of you today in Google Chrome. Visit any web page at all, choose audits, and see what those numbers bring. Now, Lighthouse is available to you inside of Chrome. You can also npm install it. So this is the kind of thing you can add to your continuous delivery pipeline as well. So this can be a key tool in your fitness functions. And it gives you very specific actionable items. Oh, look, we have a critical request chain of 3.4 seconds. I wonder what's going on there. And we can drill down and see what's going on. Now they say you could save about 5 kilobytes if you optimize your images. I might say that my images are fast enough. And that's valid. That's okay. It's up to you to decide what your goals are. I might ignore the image optimization and focus on the critical request chain. These are the kinds of things we can do in fitness functions. And of course, our good friend HTTP Archive, someone went out there on the internet, so I didn't have to, and ran a Lighthouse report on 8 million websites across the internet today, and we got a 41 on performance. That's the median number. Half of the websites did better than a 41, and half of the websites did worse. These are real numbers, but these are achievable numbers. So where does that leave us? What it means is evidence-based architecture means that a test is worth 1,000 opinions. We can measure these things. If we set up a performance budget, if we turn around and track security vulnerabilities, both in our Docker images and our frameworks, if we track accessibility errors every single time, not at the end of the process, but at the beginning of the process and every step along the way. If you have a solid, continuous deployment pipeline, if you have fitness functions tracking the health of your website, you won't be eating frozen waffles. You will be building websites of insane greatness. I believe in you. You can do this. Namaste. Thank you for your time. Thank you.
So after that presentation, I don't know about you guys, but suddenly I'm getting hungry. I actually have an interesting waffle story. So my small daughter is very picky and finicky about her foods. Yes. She actually, like small kids, she will eat instant waffles.
Yes.
But I have my own version of the insane
waffles of insane
greatness, except mine is traditional Belgium Liege waffles. That takes me slightly more than 10 minutes.
But it's worth
the time.
But
she likes them. It's worth the time. And it's good family time to make waffles together. So, big round of applause for Scott.
Thank you once again. Thank you.
Okay, so now you guys have learned a little bit about different technologies. Big congratulations to folks who were honest about using web frameworks before Scott ripped you to shreds. And now what I'm going to talk a little bit about is some other interesting developer technologies which you guys can learn about at the Oracle Code event which we're having today. This is how you know I'm a developer, is my artwork is really, really bad. So this is your average developer. And what I'm going to quickly explain to you is how you can go from being a developer to being a groundbreaker. And we're going to go through some of the technologies which you'll learn about at this conference as you transition through this progress. So the first one is serverless technology. How many folks are using serverless technology today? Oh, wow. All right, quite a lot of folks are using it today. So this is serverless, right? You throw away your servers. So not quite. The base idea of serverless is that you're going to be able to take your functions, create small functions, and then deploy them to a cloud architecture where you can run them and then achieve scale. Even though the first one here is cost is not actually the primary driver to moving to a serverless architecture. Really, what you're looking for is architectural advantages to be building smaller bite-sized increments, getting that scaling in a large cloud environment so you can actually scale from a small application to a large application and utilize off-peak hours. And then, since you're in a large cloud environment, you get low latency based upon the servers being close to where your actual end user is. This is a graph of serverless technology showing, cost of serverless versus cost if you had to buy servers. Like any good presenter, all the graphs that I show you and that you'll see the rest of today are lies. But it gives you an idea that you can get some gains by using serverless. Obviously, you're never going to be running your cluster at capacity, so you'd buy more servers than you need. And likewise, the slope here is absolutely wrong. So serverless technology will not cost you the same as buying your own servers and installing your own infrastructure on it. But it is a great technology to try out, and at Oracle, we have an open source version of serverless called the FN project. It's an entirely open source. You can run it on any cloud of your choice. So Amazon, Google, Microsoft, IBM. It also runs on Oracle Cloud. And we have a limited availability of our Cloud Function service, which is a cloud-based deployment of this technology. But I'd encourage you to try it out. It's really easy to use. It's the only commercially maintained, fully open source serverless framework. So if you want that sort of transparency where you can migrate across different cloud environments, it's a good technology for that. Okay, so taking back to our developer, so I think of serverless technology kind of like a jetpack. So this helps us take off and really get going fast. But we also, another technology which will help us get there is containers and Kubernetes. How many folks are using container technologies today? All right, so quite a lot of hands. I bet a lot of the same hands for people who are doing serverless technology. So this is kind of the history of serverless technology, or of container technology. So this is how we used to do things, right? We'd set up a server, install an operating system, deploy packages and applications directly to it. And while this is a classic architecture, kind of like the example Scott gave about just writing HTML static pages, this is the fastest you can physically get on modern hardware if you want to get straight performance. But there's a lot of advantages to having some layer in between. So here's an example using virtual machines where you can now insert a hypervisor in the middle. You have a guest operating system. You can have multiple isolated containers. This is how we were isolating applications, probably for the last 10, 15 years in production. It's a great way of having multiple applications running, doing better utilization of hardware, but you pay a slight penalty, right? So when you do virtualization, you have hypervisors, you have extra overhead, and therefore you're not going to get the full power of the computer which you're putting it on. So now we have containers to help us out with this. Containers give you a very lightweight container runtime. Basically, for your applications, they're running at almost the bare metal speeds, and you can have multiple applications running concurrently and sharing resources at an even higher level of application concurrency than you can do in virtual machines, because there's less overhead. You can have a lot of applications sharing resources and a lot of microservices or small applications running simultaneously, and then you can package up your applications into small containers. That's your effective savings in containers rather than virtual machines. Here's an example of how you could package up your applications on the container runtime, and then, getting back to my bad artwork, the great ship analogy where we're going to stick these on a very sturdy looking ship. Would you guys sail on my ship? Okay, so probably not the most seaworthy ship. Obviously, it's not going to survive this. And down goes your wonderful cluster. Kind of like in the movie, but no romance story. So what we'd actually like is we'd like a technology which lets us scale our containers across multiple machines, have easier ways of deploying it and administering it. Kubernetes helps us with this. Now we can have our whole armada of ships sailing, and this gives us a way to effectively manage a large set of machines running our containers. And at Oracle, we have a bunch of offerings which support this on our cloud services. These are all the different Oracle cloud infrastructure services. The ones which are in white are available now. So we have our container engine, we have our registry, we have pipelines. The functions, as I mentioned, is limited availability. Resource manager is limited availability, and we have a bunch more services coming online for observability and messaging. And one of the demos, which I saw a bunch of folks doing earlier today before the keynotes, is built on these technologies. So we have an AR charity challenge, which is spread out throughout the hall. By participating in this challenge, you're actually supporting a charity. We're donating all of the proceeds from the charity challenge to Technovation, which is an organization which helps students to learn about technology. And basically the way it works is you download an application on your phone. The application supports augmented reality if your phone supports it, or it falls back on a QR code. Find one of the signs and then scan it, and then it'll present you with a question. If you get the question right, then we'll give you points. Those points directly translate to dollars, not rupees. So actually quite a lot of money for the charities. So if you can, between sessions or when you're hanging out in the hallways, let's see if we can break the record. I think we made about $20,000 for Technovation at Oracle Code 1. So if Bangalore, if we can beat 20,000, then I think we'll show the US what we're capable of in India. So give it a try the AR Charity Challenge, and let's see how much we can donate to a good cause here at Oracle Code Bangalore. Okay, so containers are kind of like our utility belt. You know, like Batman, he needs all those containers and puts all his little tools and things in it. The next technology we'll chat about a little bit is digital assistants. Are folks using digital assistants today? Okay, a few folks in the audience. This is a great way to reach to a consumer audience to actually have more interaction for your audience. Some examples of digital assistants would be doing this on your phone with Facebook Messenger, WeChat, Slack, Line, different applications like that where you can have a interaction with users. What you'd probably rather be doing as well is having some sort of voice technology to interact with users. Do folks at home use Alexa or Google Home here? Okay. And then just shout out, what do you use your technology for? What do you use your chatbots at home for?
Music.
Come on. Okay, so I heard a bunch of answers. Thanks a lot for shouting it out. The most common answer that I hear in my presentations is actually what Scott said, which is music. So these are great music players. For a while, my daughter was using this for an alarm clock at home, which is brilliant because you can program individual alarms per day. You can change it at night without actually going and programming your alarm clock, but it has one fatal flaw, which is you can turn it off with your voice. So it doesn't actually work as an alarm clock, unfortunately, at least not for kids. But so the next evolution beyond chatbots is we want to actually be interacting with your chatbot using a robot like this. So we actually happen to have a robot on stage. This robot is Pepper from SoftBank Robotics. Pepper is going to be joining us in the exhibition hall, so you'll get a chance to interact with Pepper as well. But let's see if Pepper will chat with me.
Hi, my name is Pepper. How can I help you?
Who is Grace Hopper?
Grace Hopper was an American computer scientist and one of the first programmers of the Harvard Mark I computer. She was a pioneer of computer programming who invented one of the first compiler-related tools. She popularized the idea of machine-independent programming languages, which led to the development of COBOL, an early high-level programming language still in use today.
Okay, so you think that we scripted that, Scott, with the Grace Hopper Awards. All right, and let's see if we can get Pepper to do something a little more interactive. Let's see if she'll dance for us. Pepper, can you dance?
Yes, I am here.
Can you dance?
Looks at you.
Can you dance?
I love dancing. These are my latest moves. Check this out. Dance with me. Okay. Well, let's go.
All right, so a big round of applause for Pepper. So you can check out Pepper. We'll be in the exhibition hall, and you can interact with Pepper. She loves to interact with attendees. And of course, you know, it's a little bit easier when there's only one person talking to Pepper. If you have a lot of folks and a lot of noise surrounding Pepper, she might have a little bit more challenge with interactivity, but she'll be happy to dance for you. Okay, so chatbots, again, you know, I think this is kind of like a visor. Any good superhero needs their little digital assistant to talk to as they're cruising around the neighborhood. And the next technology we're going to cover quickly is blockchain. So we've had a number of folks using technologies so far. Who's using blockchain? Okay, so a few folks in the room. Okay, those are the real entrepreneurs in the audience. I think I saw 3 or 4 hands. This is not blockchain. But this is probably the technology people most closely associate with blockchain because it sits on top of the technology and it's a great consumer use case for blockchain. Anyone have any Bitcoins? Okay, what are you guys doing here? You're rich. Well, you were rich if you sold at exactly the right time. I had some Bitcoins really early on, and I made the mistake, early adopter, and it got here, and I was like, oh my God, it's going insane. And I sold, and clearly that was not. Developers, geeks don't make the best financial advisors, I would say. But the underlying technology behind Bitcoin is blockchain, and the way in which this works, and it's applicable for different business scenarios, is you have a chain of transactions, or a chain of blocks. Each new block is composed of transactions which are combined using a Merkle tree, and then you hash this together with the previous block in the chain, a nonce, a timestamp, and then this becomes the next block in the chain, and it's the miners in the case of public blockchain which give consensus on what the next correct transaction in the chain is. So that's how it does validation in the network. So Bitcoin is an example of a public blockchain network, but it's probably not what you want to be using for business transactions. First of all, you get no privacy because it's public. The transaction times are very long, seven transactions per second, and almost 10 minutes to complete a single transaction. So you can imagine if you're worried about performance, this is not exactly the technology you want to be using. Ethereum's faster than that, but again, it's still 15 seconds to complete a transaction. And you can't use some of the cool features like smart contracts or these things in a public network. However, there are private blockchain implementations which allow you to do this, such as Hyperledger, R3 Corda, and Ethereum has a private implementation. And these give you the ability to control how folks enter the network, the consensus strategy in the network. They give you unlimited data, smart contracts, control who can actually see transactions. So it's a good way of applying these technologies in a business setting. So, again, getting back to our superhero, our Groundbreaker. So I think blockchain's kind of like the drone going out and collecting information. So of course, the drone is going to enter all this information into the blockchain, so you have a generalized transactional source for this information. And the last technology you need to be a groundbreaker, which you can also find out at this event, is autonomous database technology. Autonomous database is just like a Tesla, self-driving, self-securing. I'm not sure about that for Tesla. Self-repairing. Also not sure about that for Tesla. But the autonomous database makes it very easy to get up and running with the database as a developer. So you can create tables quickly, do in-database analytics with SQL, ML, and R. It's very fast and elastic, so you can scale up the database very quickly. Provisioning the database is very simple. So you answer these 6 questions. Has anyone tried to install Oracle database? 18, 19? Yeah, so probably more than 6 questions, right? Slightly. So this is a database that your average developer can actually install, use, and get up and running without going through all that overhead of getting a full-featured database. And probably the most interesting feature is the automatic indexing capability, which has been added to the Oracle database. So it uses an expert system. It assesses your workloads and the utilization, identifies candidates, and will automatically create the indexes for you on the fly. So you can see what it's doing and all the tuning, and we ran this on the NetSuite line of products to see what it would do compared to the hand-tuned queries, which we have for the product. So on the left is the expert system, so that's us tuning our own queries. On the right is what the autonomous database algorithm came up with, and you can see that the elapsed time of queries is very close. But the number of queries for the autonomous generated indexes is much smaller. So this shows you that even in a large realistic application, autonomous database automatic indexing can do a great job of creating, assessing, and doing the right performance tuning of your application without you being a database tuning guru. So it's fast, eliminates complexity. You don't need a DBA for support. It's one database for a bunch of different types of technologies. It doesn't just support relational models. You can do JSON, spatial, graph, text. And then you can also use Apex as a low-code environment for coding against the autonomous database. OK, so getting back to our Groundbreaker example. So autonomous database, of course, is our self-driving car, which is going to help us. And then using these technologies, you too can be a groundbreaker. So to talk a little bit more about the Oracle technologies which we develop, I'm going to invite Ravi Pinto, who's Director of Product Management, to join me on stage. Ravi.
How are you, Stephen? Thank you. Hello, Bangalore. How are you doing?
Oh, let me give you the clicker.
Oh, yeah. Thank you. How are you doing? I didn't hear anything. Nice. I only heard Scott. And I think, you know, he is happy because he's now down sitting and watching. So he doesn't have any more the limelight to be worried about what he's going to talk. But what I'm going to talk, I'm pretty clear about. Stephen talked about a lot of services that help application developers. And what I want to focus on is what Oracle's doing for cloud-native application development, right? Three things that are defining our strategy. First of all, from the perspective of the culture, okay? Application development and application delivery has become much more agile, much more rapid. There is more interaction between developers and ops, right? So that particular factor is one thing that we look at when we define the cloud-native application strategy from Oracle perspective. The second is open source, right? Or the ability for you to get code, very high quality code, which can be deployed in open source, right? It's called democratization of code. No longer is code like Kubernetes sitting in Google's source code repository for Google alone, but it's out in the wild for everybody to use. I saw the number of hands that went up when Stephen asked for how many people are using Kubernetes, right? And the third thing is the cloud itself, right? Now you have the compute, the storage, and the networking available to you to set up what you want, and it gives you immense elasticity. So based on these, we've created the Oracle Cloud Infrastructure, okay? Oracle Cloud Infrastructure, of course, lets you run Oracle Database Cloud. Stephen talked about autonomous database, that's available there. We have customers who are using our cloud platform services, like the Java Cloud Service, the Integration Cloud Service, etc. And then we have hypervisors, so you can run workloads on the Oracle Cloud Infrastructure. But what I want to focus on and take a little further is this particular layer that talks specifically about the features that are available for cloud-native application development. That's monitoring and management, so you get metrics to instrument your code and find how you can create better performance. We've got streaming, so if you are doing applications which require data streaming, Kafka style, we've got the streaming service for that. The developer tools, so plugins that help with developer productivity, CI/CD pipelines, etc., and help with tools like Terraform for you to quickly provision, make changes into the setup, and all that, right? So all this is part of our cloud-native application stack that then gets deployed on containers and clusters of containers using Kubernetes. So you also have the serverless functionality that's in limited availability right now and will be going general availability very soon. Which means that you can build your applications, big data applications, AI/ML applications, or applications that are based on microservices and that need to scale a lot. So very specifically from a cloud-native application perspective, we are providing an entire stack That stack runs on a managed service, a Kubernetes managed service. What that essentially means is you just specify how big a cluster you want, and we set it up and we manage it for you. Then we have Resource Manager, which is Terraform as a service. There is an OCI registry, which is the Docker registry that's available to you. You don't need to go to Docker Hub for registry functions. Then the functions, which is the serverless, streaming, which is Kafka-style data streaming, and the container pipelines for your CI/CD. And then, of course, on top of it, notification, cloud events, which is the next big thing that's happening on event-based architecture for cloud-native applications. The one thing that I want to add over here is, there are trials available. You would have seen the shortcode for the trial, so you can go ahead and sign up for the trial. And very soon, we will have an availability region, a data center region for India, okay? So you can create applications which have low latency, are based in India. If you have data residency issues, you can deploy your applications there and, take all the benefit of the Oracle Cloud infrastructure. Thank you very much. Thanks, Nick.
Before you leave, Ravi, so we also have a little contest to announce.
Okay.
You can put the slides back up. Okay. So let me go back one more time. Okay.
Yeah.
So the contest is for the coolest coder. Use the hashtag #coolestcoder. And at Oracle India. Follow Oracle India on Twitter. Let's see. Hashtag Oracle Code and Coolest Coder. At 11 o'clock out in the hallway, for the best tweets, we're going to put them up on the wall, and then we're going to have some prizes to give out, some goodies. So during the keynotes, use these two hashtags, #CoolestCoder and #OracleCode, and then you'll be entered into this contest. So thank you, Ravi.
Welcome. And that sort of disqualifies me because I haven't been using coolest coder hashtag. don't do that. Use the hashtag coolest coder in your tweets as well, right? All the best. Thank you.
Thank you. Okay, and I want to introduce our second keynote speaker. So, we talked a little bit about performance in the first keynote, and we have a technology which is highly relevant for performance, which is a high-performance multi-language runtime that we're going to talk about today, which is one of the technologies, it's open source technology, which we develop at Oracle Labs. So without further ado, I want to invite, there's our Groundbreaker. I want to invite Amit Pal Singh to the stage. Please join me.
Hi, everybody. Can you hear me? Yeah. All right. Good morning. Yeah. Just give me 1 sec. I'm just going to share the whole desktop. So, you just share everything? Yeah. All right, great. I'm just sharing my entire desktop, so it'll be much easier. Okay, so just to introduce, right? I mean, you heard a lot of good presentations earlier today. I'm going to be talking about GraalVM. Maybe you can turn up the mic a bit if there's a way of increasing the volume. So GraalVM is a high-performance coding environment, right? So what it is the idea is that you have a universal machine language runtime. And I've recently just joined the Oracle Labs team. And with that, it's very exciting times because, I'm working across the Asia-Pacific and Japan region. And I'm really happy to be here showing you guys a couple of different demos that's going to be quite exciting, and after this, I'm available outside as well. So This is a safe harbor statement because a lot of these things are new and relatively, coming soon to the market. Since Oracle Labs, we identify and explore new technologies, and we actually bring these to the market that will substantially advance a lot of the types of innovation that you see, right? So there's a lot of PhDs and folks who have a lot of masters and so forth. So I'm not one of those PhDs, right? But I am one of those stars in one of those regions here. So I'm based out of Singapore. We are actually distributed across several locations, in the Europe, US, Asia, as well as Australia. So GraalVM is a high-performance language virtualization layer, right? So with that, you can actually theoretically run it across different OS or operating systems, right? It can be embedded, you can actually run it as a native image, and you will see that there's a lot of benefits, especially if you have been using things like JVM technologies and so forth. So you can actually run it as a part of OpenJDK. You can run it as an extended application, extended Java application, and things like that, right? So the world is polyglot. So what does that mean, right? So with GraalVM, we've seen a lot of different types of heavyweight languages that are supported by large organizations. But when we see technologies like Ruby and so forth, you need a lot of that high-performance runtime. So we've got Truffle Ruby, right? Truffle Ruby, basically, what it does is you have the ability to run it together with the GraalVM, and it gives you a lot of performance optimization. So that's already available today. You can actually just go on GitHub and use it. So it has been presented in a lot of different Ruby hackathons, for example, in Japan and so forth. Another one is Micronaut. So Micronaut is another one. How many people have heard of these services before? Okay, great. So Micronaut, even that being used quite a bit with GraalVM. So you got things like microservices, function, and things like that as well. So what it does is it actually helps to accelerate a lot of the compile time and also reduce the runtime dependencies. So you get that circular capabilities. Also reducing a lot of the serialization, deserialization methods. So that becomes another capability that can help you accelerate a lot of the different areas. Another interesting one on the bottom right is a service that has been launched, Quark. So even that actually shows the performance benefits of GraalVM and how it has been using the substrate VM, which is really the library component of it. So here you can start accelerating and using things like configuration, debugging, tracing, profiling, understanding system callbacks, instrumenting your applications, right? So we heard from Scott, it's a lot about measurement. So how do you get measurement? You want to instrument. You want to be able to hook into the runtime process, right? You want to know the internal behavior of the code, right? You want to know how it changed. So that's the key thing here. So these are some of the reasons why polyglot is very important. It breaks the boundaries, really, within code. So you're able to collaborate across different types of coding languages and also different types of groups that would be using this ecosystem. So the support for GraalVM extends across multiple languages since it's a language runtime layer, right, that's been optimized. So you got Java, Scala, Kotlin, things like that. JavaScript on top of it. Ruby, as you saw, Truffle Ruby. Fast R implementation, so you're running things like Apache, Spark, and so forth. You can actually get a lot of, even within Python, things like your data science libraries, NumPy, SciPy, things like that as well. Similar to C and C++, you can get LLVM interpreters, so you can actually run it, and you'll be able to use your own compiler and optimize things accordingly. So all these are supported for you, including other languages that are coming, things like Rust and so forth as well. So that is the part of the compilation as well as the interpreters, right? So you're basically just converting a lot of the bytecode to machine code. We're doing it hyper fast, right? So how do we do it behind the scenes? So you might wonder, what is the secret sauce, right? Why is this faster than the rest? So I'll explain. Other areas on the lower ends of it, you will start seeing things like how you can embed it into the Oracle database. So you'll see a demo of that, how we're going to do that, and things like even MySQL and how it's supported. Here's some of the performance charts. So you can see that within Ruby, Scala, it's almost like 4 or 5 times faster. And we can even out performance against Node, V8, and all those existing engines. So Graal is obviously the one in the red, and the rest obviously being in the one in the gray. So exciting times, right? I mean, that's awesome stuff here. So you can actually do that. So what's behind the scenes? Before that, if you wanted to actually look and see what are some of the contributors, we've got hundreds of contributors. There's about over 1,000 different updates, commits that are happening in real time. So it's a very healthy project, and it's not just within Oracle. So you've got large commercial organizations using this, and we can share more about that later as well. Behind the scenes for Graal, what it does is using techniques like partial escape analysis, right? So with that, you're able to do things like static analysis, things like ahead of time compilation. So you can actually reduce the time it takes, for you to get to the machine code. Native image generation is important, and that gives you, a lot more, reduces the overhead, right? And you can run a lot of applications with less dependencies and things like that as well. So fast startup is just one of the beginnings. High performance is another. But things like introspection gives you yet another dimension to it. So native images are very important because fully from a ahead of time compilation perspective, you can actually achieve machine code, right? So reduce your CPU clock cycles as well. You'll see that. And it works with memory management. I'll touch a little bit more on the security aspects later, and what are some of the bounds checks that are occurring, and how do we actually protect things like access to these native libraries, memory sandboxing, and stuff like that as well, right? So that's the idea, right? So how we can actually do that. So we're going to be jumping into a series of demos, showing you basically what are some of the capabilities, right? So think about Graal as a holy grail of an ecosystem, and then these are kind of like your 10 things that you want to do to achieve those that mission. So the first thing we want to do is move into a demo environment. Okay, so to give you an idea, so what we're going to be doing is essentially going and showing you how a fast Java performance is actually accelerated, right? So the first thing we're going to do is, let me just show you a sample of code what you're going to be running. So it's simple program, right? So it's count uppercase. So basically, you're iterating it, multiple times and so forth. You're counting number of uppercase and so forth, and you're going over 10 million iterations. So you want to try to show the workload heaviness and so forth. So with that, we're actually going to run it using Graal. And let me just begin here. So the first thing is you want to be able to check and see what is the Java version that's running. So you clearly see that we are using the existing GraalVM Java version, right? So with that, we are able to start and compile a count uppercase program that generates the machine code from there. And we're going to run a set of iterations. So with this existing iteration that we're going to run is using the GraalVM engine. So with that, you'll see iteration 1, 2, 3. I'm actually running it on a dual-core machine, so that's the Mac. So you can see that, almost iteration, so for example, 3 onwards, you're looking at things like, 3 milliseconds, 4 milliseconds, and so forth. That's consistent all the way till the 10th iteration. So I'm going to run the same thing now without the GraalVM compiler. That means just using the regular compiler on the machine. And here you'll start to see that iteration 3 or 4 onwards, it's actually taking a much longer time, right? So it's almost 609 consistently going all the way from the 4th till the 10th onwards. And comparatively with Graal, you're getting 5, 6, 7 times the speed, right? And that's just only a dual core machine here, right? So that's the first example of what we're going to be showing in terms of how many people can see that at the back? Well, one person can see it. Okay, great. This is really good eyesight. So people can see it in the front? Okay, great. So second, right, so that's a high performance environment and things like that. So what we're going to be showing you second is, an important part is what's the low performance instance startup, low footprint, right? So how do we do that? So the first thing is we want to be able to generate a native image of this Graal, of a program, right? So we have this top 10 program, and basically top 10 program, that's what it is, right? So you can see it's going through different lines, and you have things like your collectors and so forth. So we're going to be running that using GraalVM again, and we're going to see what are some of the speed that we can actually get, right? So we have actually created the native image, right? So let me run it initially. So that's taking about 0.22 seconds in terms of real performance hit. So let's create that native image. And then after we create the native image, it'll take some time and actually generate, show you the different queues or the different class lists that are being generated. And then from there, we're going to run it again. Then we'll actually see how much faster it is. You can actually see in the previous iteration, so it'll be something like 0.02, 0.04 seconds, and so forth, right? Even the memory utilization is actually shown pretty clearly over there. So it's just breaking down in terms of the different top 10. And one of the additional features that is being introduced is it's not only just the escape analysis, but also the advanced inlining, right? So you can inline, and that actually gives you a lot of that overhead performance capabilities as well. So let's give this another few milliseconds. So you count milliseconds. It's parsing, inlining, compiling image. Okay, so from here, we're going to run basically refer back to to a test here. So we generated native image. So we're going to skip that part. We're going to actually run this part here, right? So for the interest of time, let me just probably have it there, but so you can see it's almost 0.01, right? That's a remarkable increase from what we saw earlier. There's like 30, 40 times difference, right? So this is not even looking at the cross-language dependencies. So if you look at it within the language itself, within the host language, and you're calling third-party languages, that's almost over 100 times increase that you can get, right, within that spectrum. Third thing that we're going to be looking at is polyglots. So this part is even more interesting. So within the polyglot environment, you're basically looking at code that is written specifically, from an express standpoint and so forth, but you've got a mixed variety. So you're using Java for a big integer problem, and you're using Python for your, R for your plotting mechanisms and so forth, right? And how do we run all that together? So we're going to launch that. You'll see it running on the port, and once we execute it, this mixed language runtime will be able to show you a graph that's running in real time here. So in that sense, if I keep refreshing that, it will paint itself different forms of 3 different axes, right? Of 3 different types of forms all running together. And so that's pretty interesting because polyglot is a very, very important part of showing you how you can run different languages, host and foreign languages within that same perspective, right? So that's the second part. The third the third part of what really wanted to show you guys, which is the ability to combine JavaScript, R, and also Java in that sense, right? What we just saw. So we have actually, behind the scenes, even done things like install npm and so forth as well. So that's that. Now, let's look at another one where you want to be able to run native languages. So for example, how many people write C, C++ code here? That's true, exactly. So in colleges now, it's all starting with Java, which is why you should start with this. So it'll make it a lot easier, so you can compile your C, and then you can basically just run that LVM bytecode here, bitcode. So, so we've done that, and once we do that, you can see that this is just a gzip program, right? And from there, when we execute it, it runs behind the scenes, and it's just in the interest of time and so forth. So what we did was we actually ran gzip, compiled it, C generated from a C compiler, any one that you're already using, for example, and then ran that using our LVM li script, right? So that was done on our side, and we can actually see that it actually compiles and it runs. So you can actually look at the entire runtime of that sample application. So that's the fourth aspect. So you're basically able to run native languages, so even C, C++ using GraalVM. Now, the fifth one is more exciting. So how many people have gone to an interview and you've been asked some question on FizzBuzz? Anybody? Wow. So you went through the interview, I suppose you made it, right? Oh, great. That's awesome. So that's a very important point. So FizzBuzz is used quite a bit. So what it is basically just printing out, when you have multiples of 3, multiples of 5, you print out FizzBuzz, or Fizz, and then Buzz, and when it's both multiple of 3 and 5, and then you print out FizzBuzz, right? So here's the code, and you can see it. And so obviously this one is in JS, right? So let's now run this. So what we're going to do is we're going to do some, with this JS, we're going to inspect it using a Chrome debugger. So GraalVM can run together a Chrome debugger, and you can do a lot of tracing and profiling. So it's generated a unique URL in Chrome. So I'm just going to use that, concatenate that, and run it here. So within Chrome debugger, you can actually see that you can actually map and actually add start breakpoints. So I'm going to add a breakpoint and iterate through the different types of functional calls, right? So as it's generating the different functional calls, you will start seeing the output on the console below, right? So whether it's 2, Fizz, once multiple of 3 and 4 and 5. And behind the scenes, you're able to create breakpoints, and then you can actually look at the details of really what's happening from system callbacks and traces of that sort. So you can actually drill down and debug to where you're having specific issues and look at that specific iteration and what's happening, right? So all comes back to ability for you to be able to walk through the different steps. And on top of that, you might want to be able to generate more data. So on the visual aspect of what's going on behind the scenes. So we have spun up Visual VM. So Visual VM basically gives you an idea of that particular JS application. So you ran the Ruby aspect of it as well. So you can actually drill down and see that within that Ruby application, what's the heap dump? And within that heap dump, you can even start looking at things like your objects, right? You can drill down to specific objects, what is the count, the size, and details like how long was retained and information of that sort. You can start obviously doing monitoring of that. Here what we are saying is a Ruby specific application, not just Java, right? So in that sense. So there's quite a bit that you can actually drill down. So all this goes down to performance metrics that you really need to be able to be doing as part of instrumentation and so forth. So this data, obviously, you can pull it into any dashboard. So you in DevOps, you have like 100 dashboards. So you can pull this data, giving you more insights into what's happening, especially from heap dumps and areas like that and so forth. So that's on the part on the Chrome debugging aspect, and how GraalVM runs together with it. Now, the sixth piece, which is pretty interesting, is how do you extend a JVM-based application, right? And you want to just be able to run, say, a few different iterations of arrays, resorting arrays into the right order and things like that. So we have that same thing, and you can actually run it from a single interface. So we've done that, and from there we can see that whether you extend it using JS, Python, or Ruby, it's giving you all those right output that you expected and so forth as well. So within GraalVM, you can actually just run, it's just a runtime environment, and also compilation available to you behind the scenes, right? So that's the interface part. Other specific ones that we don't have the time, but I will just kind of walk you through it. You can actually extend a native application as well. And on top of that, you can actually use Java code as a native library. And so this becomes like your embeddings and things like that. So you can use distance libraries and so forth. I'm going to just spend a few minutes on the database part. So we're going to attempt to run Node together with Oracle database. So we can actually, how many people have done that? Run Node on the Oracle database, or in the Oracle database? All right, okay. There's a few people. One of the mics is louder and not, okay, so that's why you need a consistent ecosystem. So, so the interesting part here is that you can actually, let me just go back to the slides. Once you enter the demo, it's easy to forget about the slides. But just to give you a visual on the database aspect is that there's a great move towards using JavaScript and Python together with the Oracle database, so how you can actually do that with speed. So we're going to show you a quick demo of that. That's just a visual. So this is actually using a multi-language engine, like a multi-language runtime engine for the database if you have a plugin. And so let me just go ahead and, so we have the Oracle database running behind the scenes over here. And what we are doing basically is, let me just exit from here. So that's the Docker instance that we have actually drilled into. From here, let's just set, okay, let me just create a new directory, be easier. Okay, so let's call it BLR, Bangalore. Oh wait, what am I doing here? Yeah. Okay, it's there. So, okay, so let's just run through a couple of iterations. How do you set it up with the database? So, well, first thing we're going to do is do an echo for the package JSON, and subsequently we're going to be running a npm install for validator. Validator basically looks at it's if you go on the npm website, you can see certain characters, input validation, stuff like that. So this will run the validator. That's just a bunch of warnings that you can ignore. And then after that, you want to basically go to the next step on the types specific. And then you're going to run a command to actually move some of these node packages to the database so they can actually run from there, and you'll see it from a SQL command, right? So let me actually do that. dbjs, that should do it. So it just takes a minute. And from then, we will basically get into the database itself and run a command that basically at the end of that to do a select validator to see what is the output. So if the validator expression is actually matching the, or is part of the SQL expression, so it should show us a result. Right, so it has. So in that sense, right, you are able to do that from using the multi-language environment that's built into our Oracle database, and also similarly to MySQL, and work together with npm node packages via the GraalVM, right? So that's all pretty interesting. So those are the main things that really wanted to show you guys in that short time. Let me go back to the presentation. Okay, so you kind of seen, high performance optimization of Java, right? From the speed, the before and after effects. You've seen the areas on how the startup time almost down to 0.01 seconds. You've seen how we went through the polyglot example of the 3D cube, right? And that showed you how you could run all the different types of languages and then chart the polyglot using the polyglot API of GraalVM. And then we ran some native languages in JVM. Followed by then you had some tools, for example, that we ran accordingly as well. We also extended the JVM application. We ran Java code as a native binary, you saw that. And then the interesting parts where we ran the polyglot in the database as well. Obviously, the biggest challenge here would be, and I would encourage all of you guys to bring your own language, right? So some of the customers have done that. And in fact, I think I'm going to be sharing some of the customers and what they have done. We have two flavors. One is the community edition. Second is the enterprise edition. So obviously, the enterprise edition comes with a lot more security features and things like that. And the part that's interesting is you don't have to wait for the cloud. So this can run on premise. So how many people are happy with that, right? So nobody jumping up and down. Okay, great. Why is it secure? Okay, so I think you saw, as Scott mentioned, there's a lot of vulnerabilities. It's not one person who's going to be able to manage all of that, right? So the only way to defeat it is, so the hacks happen via code. So you're going to have to do it from within the code. You're not going to be able to wait for Docker, come up for a patch, and then you're going to orchestrate that patch. The time gap is too short, too long for you, right? Advanced persistent threats will go on way faster than you can even think. And you probably have replicated that same bug in a lot of different instances. So with GraalVM, because you can harness or get the ability to have execution of code going through a central funnel down to your OS, right? Different types of OS. You're able to have threat safety. You can have memory sandboxing as well. So you can prevent things like side channel attacks, reflected attacks, buffer overflow attacks. You can look at pointers and memory safety that you've not turned on by default and things like that. So you can create that kind of sandbox execution of native code, which is very powerful. So you are able to now respond to real-time hacking by actually real-time ecosystem of compilation as well as runtime execution. So why Graal? Because it's fast, right? And speed is not, of course, an important part, but accuracy is, right? So measurement and criteria and so forth. So you can support a wide variety of languages, things like Java, Scala, and even Groovy, Clojure, and so forth. And I think you even saw just now things like R, fast R, and using a lot of data science types, whether using it for websites, just Ruby, or JavaScript, or even more embedded languages where you're Java, C++, and so forth. So that's where the polyglot nature of Graal, together with the embedded capability, will give you that kind of reach that you need to be able to break the boundaries of language as you're coding to innovate, right? So interoperability is key, right? So interoperability is one of the things that we're trying to achieve here. So ultimately, we will support almost all the languages that are available to you today. So you already can see, we already even had questions on things like COBOL and so forth. So if you generate things like C files from there, you can run it using our LLI capabilities, and you can use our language runtime, which is actually, I forgot to mention, it's called Truffle, like chocolates, right? So that's the language implementation layer. So in essence, the GraalVM, gives you that power to support all these different languages, right? On the left-hand side, you see Java and Scala, and on the top, they are benefiting from the Truffle framework. So that's the language implementation layer, right? So, and then at the same time, if you want LLVM, we can do the same thing. I would encourage you to join the community effort. This is an exciting time. This is being used quite a bit a lot. A lot of the labs that I was running basically are from GitHub, so you can see and follow that along as after you leave today. And test your applications. You know, integrate GraalVM into one of your Java apps. See the before after. See the speed of what happens. Run multiple different types of languages from within Graal. You know, give it a shot. Try the polyglot API. Try to break it. You know, run your own domain-specific languages and build your own language. We've got a customer who's doing that. Join the conversation as well. Just to end, I think an interesting part here is that I think Chris is somewhere in the audience, right? So, is he here? So he's from Twitter. So he's going to be actually presenting how Twitter is one of the first ones to use GraalVM, right? They actually Graal at that point, and they're able to get a lot of performance tuning optimization from the compilation time, and even, so they actually built a lot of their own frameworks on top of it as well. So, as you can imagine, Twitter is doing it into the, you know, the kind of performance metrics that they're looking at. Another one that's interesting is Goldman Sachs. So that's a financial company, and they've been running pricing and risk simulations using GraalVM. So they created actually their own language called Slang, right, on top of it. So, which is why I'm saying bring your own language. And also Disney streaming services. They've been experimenting and using GraalVM from a lot of the different areas and so forth. So that's all I really have for you today. And apologies, my voice wasn't very good, but hopefully you got an idea of what Graal can do. I'll be outside, so I'll be maybe using a robot to talk or something, but I can show you everything that's going on in terms of labs and so forth. So thank you. Namaste.
Hey, thank you very much. Okay, and as Paul mentions, Chris Thallinger is going to be speaking later today, so I'd look forward to that talk. He's an excellent presenter, and you can learn a lot about doing high-performance computing on GraalVM, just like the folks at Twitter. Okay, so we have a short evacuation procedure announcement from the local hotel staff. So I'd like to invite Chanda Charan onto the stage. Mr. Charan, please join us. And he's going to say a few words just about security in the facility here. So,
thank you. Morning, ladies and gentlemen. As he introduced, my name is Chanda Charan. I'm the security manager of this hotel. Please be aware that today we are not conducting any evacuation drill. So in case of any emergency happens, you will hear a hooter sound followed by the evacuation message. For that, you don't have to react to it. We have our internal emergency team. They will react to it, and it will be acknowledged immediately and silenced. Please don't react. But if that continues, if the hooter sound continues, followed by the evacuation message also, in that case, we need your support. Calmly evacuate this area. Before that, be aware that we are sitting in second floor, and this area name is called ballroom. So you will have to evacuate this area. This room has 8 emergency exits. To your back, there are 4, and towards my left and right, there are 4. So evacuate from these exits. The moment that you exit, you will find another emergency exit. Follow the emergency exit signages, and you will have to go 2 floors down. The moment you reach down, the emergency exit lands at our emergency assembly point. So that area we all will gather, and then we will take head count and make sure that nobody is stuck, or in case if some emergency happens, hotel team is around, and do let us know. We will together work and then make sure that we all are safe. That is all that I wanted to tell you. Thank you so much. Have a great day ahead.
So thank you, Mr. Charan, for looking out for our safety. Thank you. Okay, and a few quick announcements. So Oracle 18C is now available, free for use. So you can use this for your development projects with Oracle XE. Also, you can try the latest version of Oracle Database 19C. It's currently running in the livesql.oracle.com environment, so you can try this out before upgrading to the latest database version. We have the Groundbreaker Awards, which is a peer-nominated award program. So if you have any folks who you'd like to nominate who are coworkers or who are people who you look up to online, go to the website. You can do nominations between, let's see, I guess before April 2nd. We're doing voting from April 2nd to 19th, and then we're going to announce the winners in May 21st. So go to developer.oracle.com, new face of greatness, to nominate folks. And in general, check out developer.oracle.com for information about all the technologies which we've talked about and you've seen today. For the latest schedule info, use the mobile application. You need to download the Oracle Events mobile app, and then you add in the plus sign and choose Oracle Code Bangalore for this event. Then it will give you the full schedule on your mobile device. This is the best place to get updated schedule info. The website is also updated, but the very latest information you'll get on the mobile app, such as my session, which got added to the schedule yesterday. And then tweet with hashtag Groundbreakers, tweet to @OracleDevs, and we also have the Twitter contest going on, which I'll remind you about shortly. But here is the high-level agenda, and I'm just going to highlight a couple things which I think are particularly important, such as lunch, 1:30, and the afternoon coffee break. That's also very important. And my favorite activity of all is the Women in Technology session. So we're going to have some snacks for folks. We'll do it at 1620 downstairs at the restaurant Durbar. And this is open both for women who are attending, but also for allies of women. So if you want to support women in the workforce and make sure that they have a better environment, we also encourage men to join as well. So you can also sign up for a $500 cloud trial using this code, code 19BLR. As attendees at the event, if you use the same email address you registered for the event, you will get access to this $500 offer, which is larger than the normal cloud trial. So take a photo of the URL and then log on later, and you can get your $500 free trial. I'm going to leave this up, and something else important that you guys need. So you, of course, need your T-shirt, Oracle Groundbreakers T-shirt. The T-shirts will be available starting from 3 p.m. downstairs where you registered. So as you're leaving, you can pick up T-shirts on your way out. Wear them proudly, show to your colleagues that you were part of the Oracle Code event. So finally, just remember that we have a Twitter contest going on outside the hall. So if you tweeted using hashtag Oracle Code and hashtag something greatness, I have a bad memory, then
Coolest
please,
coder.
What?
Coolest coder.
Coolest coder, thank you. Hashtag coolest coder. Then please join us outside by the tweet wall for some prizes. So thank you guys, and please enjoy the program we have today for you.
Coolest coder and Oracle Code. Please use these two hashtags today. Thank you. Good news is we are already trending on Bangalore Twitter. So take it to the top handle. Thank you.